In this section, we're going to talk about polynomials. So let's kind of talk about, before we talk about polynomials, so kind of remember from last year, poly means more than one what? Nomials or monomials. So before we talk about polynomials, we're going to talk about monomials. So monomials means one of them before we talk about many. But remember first, polynomials, when we talk about polynomials, they can only have positive powers. So like this. So x to the first, x to the second, x to the third. So we are just talking about positive powers and also just integers. So we're not talking about like x to the 1/2. And then if you don't remember what x to the 1/2 is, we'll talk about that much later. Okay, so let's kind of look at the general graphs of x to the first, x to the second, x to the third, x to the fourth. And what we're going to do is kind of do a quick exploration of how they are similar to each other by the powers that they have. So x to the first, if you recall, is a linear line. X squared, if you recall, is parabola. X to the third, so the cubic function, well, x cubed looks like this, but we're going to just talk about in general. Well, actually, let's just do that. Okay. And then x to the fourth looks like this. So do you notice any similarities and differences between the powers for the monomials? You can see that the end, right? The ends of the functions, some of them look similar because of the powers, and some of them look different. And then if we want to categorize them, we can pretty much say that the ones with the odd powers have the ends going in the same direction, and then the ones with the even powers have the ends going in the same directions. And so we can actually conclude that this is true for all of the monomials. So what we can say is that all the ones with odd powers ends up having the two directions going opposite. And then the ones with the even powers, they end up going in the same direction. Now let's talk about end behavior. So we talked about end behavior in chapter 1. We're saying basically where does the function go at the end, and then we talked about how to reduce the function so that we can see what function it's similar to. But now what we're going to do is we're going to describe this end behavior using limits. So limit is a way of telling people where is the end going. So this is how you write limit notation. So limit, we just write LIM. And then notice how this is written right below it. So please do write below it. Don't write somewhere else. So it's saying as x is going to, okay, as x is going to, and then this is basically a place for you to write x values. So I'm going to kind of write these explanation as we go. So this is the x value that it's going to. So we're saying, oh, as x is going to this place, and then here, this is the where you put the function. So the equation. And then you're saying, oh, then the function is going to here. So this is the y value that the function is going to. All right, for example, if we're saying x is going to infinity. Well, first of all, let's talk about infinity. Where is infinity? Infinity just means a very, very big number, a very, very, very big positive number, right? So then when x is going to a very big number, so we're talking about first this one for x. So when x is going to infinity, so you see how my arrow is pointing this way. When x is going to infinity, the question is the function, or we can say y. The function is going where? Okay, that is the red line. The red line is going to which direction in the y direction? Well, the graph is going to go up. Up means very large positive number. So then we would say y is going to infinity as well. Okay, so let's practice. So let's talk about this in behavior here. I'm going to do everything in green. As x is going to infinity, okay, so as x is going to infinity, y is going up. So then we would say f of x is going to infinity. Okay, notice the way I'm writing this. This is all the same level. This is like a subscript underneath limit. Okay, so please do write it this way. All right, let's do the one on the left. Limit as x is going to where? This time x is going to the left. Left means negative infinity. So x is going to negative infinity. Where is y going? Y is going to go down. So then we would say f of x is going to down. Down means negative infinity. All right, let's try another one. X squared. So let's look at this one on the right. When x is going this way, y is going up. I know there's a slight curve, but we don't really care about the curve. We just care about what happens at the end, therefore end behavior. So limit as x is going to infinity, f of x is going to infinity because it's going up. Let's do the one on the left. Limit as x is going to negative infinity, y or f of x is going up. Up we say infinity. So remember last year we called the end behavior up or down up. It's the same idea. Instead of up we say infinity. Instead of down we say negative infinity. All right, let's go ahead and have you try x cubed and x to the fourth. All right, go ahead and check your answers. So, all right, so let's go ahead and summarize. So the characteristics of the monomial is that the odd function, odd means the powers are odd, it starts from negative infinity and it goes to infinity. So it starts from the bottom and goes up. Even ones, that means the even powers, starts from infinity and then goes to infinity. The other thing that we're going to notice later on is that the number of terms is related to the highest degree. So what does the number of terms mean? So instead of drawing it actually as an x cubed, if I actually had a polynomial with an x cubed, I would actually see it going like this. And then x to the fourth would actually look more like this. So then what we can actually see is that there is something called like the number of terms. So for example, x to the first, just one, kind of one direction. X squared, 1, 2. X cubed, 1, 2, 3. X to the fourth, 1, 2, 3, 4. So let's guess. How would x to the seventh look like? How would x to the seventh look like? First of all, you ask yourself, is this odd or even? It's odd. Odd means what? Well, how would the end behavior look like? One, it will start from the bottom and then goes up, right? So then, and then the other thing is how many turns would it have? It will have 7 turns, usually. So it could look something like this, start from the bottom. 1, 2, 3, 4, 5, 6, 7. Okay, probably how it's going to look like. All right, and then so we can actually say the number of maximum local extrema, and then it's always going to be local for a polynomial because it's always going to be unbounded, is always going to be what? Then the highest degree. All right, maximum extrema. So let's look at x to the first. X to the first has no extrema, right? We don't have a hill, we don't have a valley. And then if we look at x squared, we have one absolute minimum. And then if we look at x cubed, it has 2 extrema. If we will look at x to the fourth, 1, 2, 3, 3 extrema. So how will we summarize that as related to the powers? Well, the maximum extrema it could have is always going to be one less than the total powers. And then we always know that the number of zeros is the same as the highest degree. Now, how is that related to a polynomial? Well, the monomial with the highest degree dominates the behavior of the polynomial. So that means we can actually predict the end behavior of any polynomial by memorizing the behavior of the leading term. Okay, so let's look at an example. Predict the end behavior of the polynomial by writing in terms of limits. So all we really need to care about, so how would this polynomial look like? It will look like the highest term. So whatever that monomial is, the degree is, it will look like that. So the highest degree is 5, so it's going to look like a fifth degree. So then this goes, because it's odd, it starts from the bottom, and then it has a maximum of 5 turns. So 1, 2, 3, 4, 5. Now let's write the end behavior using limits. So this side is limit as x goes to negative infinity, y goes to negative infinity, and then this side, limit as x goes to infinity, y goes to infinity. All right, let's go ahead and have you try this one, number 2. Figure out the highest term and then guess what the end behavior is going to look like using limits. All right, this is a tricky question. I don't know if you got it right. This one, the trick is there is a negative on the leading coefficient, and remember, negative means that the polynomial is going to reflect over the x-axis, so it's actually going to point down. Now let's practice. So we are going to learn how to sketch the polynomial without actually having a graphing calculator. So we can do that by knowing a few things. First, predict the end behavior using the highest degree. So, we got to kind of know where it starts and where it ends. Next, we're going to find the zeros of the function. So we want to know where it crosses the x-axis. And then from those zeros, we want to know the multiplicity. So I'm not sure if you remember from last year, multiplicity. Multiplicity is the number of repeated zeros. All right. So how is that going to help us? So like, for example, if you had a function that is x minus 2 squared times x plus 3, and then if we want to figure out where the zeros are, we make it equal to 0, right? And then so x equals 2 and then x equals minus 3 are the zeros. However, x equals 2, there are 2 of them, right? Because it's a square, so that means there are 2 of the same thing. And then so what we can do is we write m equals 2, meaning there are 2 of them. X equals negative 3, there's only 1 of them. It's kind of irrelevant. You don't have to write m equals 1. But for clarity's sake, I'm going to just write m equals 1. You really don't need to, because one of them just, you don't have to tell me there's one of them. You tell me if there's more than one. Anyways, so odd multiplicity means there is only 1 or 3 or 5 or odd numbers of them. And then even multiplicity means there are 2 or 4 or 6, so even numbers of that same 0. So how does that affect the graph? So if it's odd multiplicity, then that means on that 0 or on that x-intercept, it's going to cross the x-axis. Even multiplicity means that it's going to bounce off the x-axis. Okay, so at this point, you're probably thinking, what does crossing, what does bouncing mean? Let's look at an example. Sketch the graph of this without graphing calculator. All right, so first thing, end behavior. End behavior depends on the highest degree. Third degree, we know it's going to go like this, something like that. Next, we want to find the zeros. How do we find the zeros? Let's take out our Algebra 2 skills. We're going to factor and solve. So we can see that x is repeating throughout all the terms, so we're going to factor out x and then just factor that. So x is equal to 0, 3, and minus 2. All right, so let's go ahead and draw a very preliminary sketch. So we know that there are 3 zeros on here, 0, 3, and negative 2. I know that this side is going to go down, this side is going to go up. Remember, zeros means that's the only ones it's going to cross the x-axis. So next, the question is, how is it going to look like? Is it going to look like this? Or is it going to look like, let's see. I guess that's the only way it can look, huh? If we want to go through all 3 of them. So like that. Let's try another one. This one's nice. Everything is already factored. So let's see. How many degrees is this? There are 2 degrees from here, 1 degree from here, so a total of 3 degrees. So if you're not sure why it's 3 degrees, you're looking at it as in like, that's x, that's another x. Remember, degrees has to do with the polynomial. So you would actually have to multiply everything out and look at the polynomial. But you don't really have to do that. You can just count how many zeros there are, right? 2 here, 1 here, so that's a total of 3 degrees. All right, same thing as before, 3 degrees. We know the end behavior, especially since there's no negative in the front. We know there are 2 x equals 2 and 1 x equals negative 1. So let's write that out. X equals 2, there are 2 of them. And then x equals negative 1, there is 1 of them. So let's kind of draw a very quick picture. 2, negative 1. I know it's 3 degrees, so this side must go down, this side must go up. All right, so now the question is it connected like this? Or is it connected like this? Right? You didn't think there were 2 ways of actually happening, right? But there are. So the question is, how is it going to look? Well, let's look at our hint here. Odd degrees means it's going to cross. Even means it's going to bounce off. So what does that actually mean? This is odd, so it's going to cross. This is even, so it's going to bounce off. Cross means that it's going to cross at negative 1, so it's going to cross over. Bounce off means it's going to not cross the x-axis, so it's going to bounce off like this. So then actually this is the correct way to graph it. All right, let's have you try. So you have this one. First thing, end behavior, depending on the highest degree. Second thing, find the zeros, find how many of them, multiplicity of each one, and then sketch a graph. All right, this one is going to kind of see how much you remember from Algebra 2. How do you factor this? You're going to have to do it by grouping. Okay, so go ahead and pause the video and come back and check your answer. All right, go ahead and check your answer. So after we factored, we have 3 different zeros, and so it must cross all 3 of them because the multiplicities are all 1. All right, so let's give you one more to try. This time I'm just gonna give you random factored ones. I just want to make sure that you can figure out the multiplicity correctly. All right, this one's a little tricky. We have 3 zeros or 3 different numbers, but then they all have different multiplicity. And notice how I put a negative in the front. So this is gonna change things a little bit. Okay, first thing, figure out the end behavior by the total number of degrees. So you want to count how many zeros there are. Second, find the zeros and their multiplicity. And then third thing, you're going to sketch. So go ahead and pause the video and then come back and check your answer. All right, we got to this point. So I don't know if you finished, but I'm gonna kind of show you how to finish this one. This is 6 degrees, so that's even. So either both of them are going up or both of them are going down. Because of the negative leading coefficient, I know it's going to both go down. Now is it's a question of which one's gonna cross, which one's gonna bounce. So if it's even, it bounces off. If it's odd, it crosses. So at 3, it's going to cross. At 0, it's going to cross. And then at -2, it's going to bounce. Okay, we know that it's going to turn 6 times, so you could make this turn 6 times if you want, but it really doesn't matter. But sorry, the graph should look something like this.